Hello, this is Dr. Hanaa Assil, and today we're talking about calculation of molecular mass and any calculations related to that. So let us just take a look at what is molecular mass. Molecular mass, which is also referred to as mass of one mole, or we're going to be talking about it as MR. It is actually the sum of the atomic masses of the atoms in the molecule. So if we have a certain molecule, you just add up the masses according to the molecular formula, and that will give you the molecular mass. So in order to do that, we have to remind ourselves how to write a molecular formula. Remember that to write a chemical formula, we write the symbols for each element, and then we put the valency of one under the other. And we said, how do we get valency? Well, some things you can get from the periodic table. So for example, anything in group 1, we should know, has 1 electron in its outermost shell. It needs to lose it, so we say that its valency is 1. Valency is basically the number of electrons that we need to lose or gain in order to have a full outer shell. Anything in group 2 has 2 electrons in its outermost shell. It needs to lose it, so its valency is 2. Anything in group 3 will have a valency of 3. Anything in group 4 will have a valency of 4. Now, anything in group 5 needs to gain 3 electrons so that the total will be 8. So its valency is 3. Anything in group 6 needs to gain 2 electrons, so its valency is 2. Anything in group 7 needs to gain 1 electron, so its valency is 1. But there are some things that are not in the periodic table, and these things you have to memorize. So you have to know then that when we say something hydroxide, hydroxide is OH and its valency is 1. Nitrate is NO3, its valency is 1. Nitrite is NO2, valency 1. Ammonium, NH4, valency 1. Now, those that have a valency of 2 are carbonate and sulfate. Carbonate is CO3 and sulfate is SO4. Phosphate is the only one that we deal with that has a valency of 3, and that is PO4. So once we write the chemical symbols for the formula we're looking at, then we can determine the mass of 1 mole. For example, if he tells me to determine the MR, or the molecular mass of ammonium sulfate, well, the first thing I need to know is how do we write the formula of ammonium sulfate? From what we just said previously, ammonium is NH4 and its valency is 1. And we said the valency of something goes under the other one. So if the valency of ammonium is 1, I do not write anything under the sulfate. Now the sulfate is SO4, that never changes. The valency of sulfate is what? It's 2, so I have to put 2 under the ammonium. Now when I need to put a number under these groups, I have to put a bracket and 2. So this is the formula of ammonium sulfate. How do I determine the molecular mass of ammonium sulfate? Well, I take a look at this. Nitrogen, we look at the periodic table. Nitrogen has a mass number of what? Remember again, the mass number is the big number. Remember, in the periodic table, each element has 2 numbers, atomic number and mass number. We said the atomic number is the smaller one. The mass number is the bigger one. So nitrogen has a mass of 14. How many nitrogens do I have? Remember that anything outside the bracket applies to everything inside the bracket. So actually here we have 2 nitrogens. So you multiply the 14 by 2. Then you add the next one. The next one is a hydrogen. Remember, the nitrogen is alone, hydrogen alone, sulfur alone, oxygen alone. Hydrogen, mass number is 1. Now, how many hydrogens do we have? You multiply these 2 numbers. The 4 applies to the hydrogen, and the 2 that's outside the bracket applies to everything inside the bracket. So actually, I have 2 times 4, which is 8 hydrogens. Plus, the next one is sulfur. Sulfur has a mass of 32 from the periodic table, and I have only 1 sulfur, so that is 32, or 32 times 1. Plus, oxygen has a mass number of 16. You look at the periodic table, the big number. How many oxygens do I have? I have 4. Now, the addition of all of this is what we call molecular mass, or mass of 1 mole, or MR. So in this case, the total is 132. So let's try another example. Aluminium sulfate. How do I write the formula of aluminium sulfate? Aluminium sulfate is, aluminium is Al, sulfate is SO4, and then the valency of aluminium is 3, so that goes under the SO4. The valency of sulfate is 2, so that goes under the aluminium. Now we bring the periodic table and we look at the mass of each of these. The mass of aluminium is 27. How many aluminiums do I have? You multiply by 2. Plus, sulfur has a mass of 32. Now, how many sulfurs do I have? We said anything outside the bracket applies to everything inside the bracket. So I have 3 sulfurs, and oxygen is 16, and I have 3 times 4, which is 12. Magnesium phosphate. How do I write magnesium phosphate? Magnesium is Mg, phosphate is PO4. Now the valency of magnesium is 2, so I put 2 under the PO4. Valency of PO4 is 3, I put 3 under the magnesium. And again, I look at the periodic table. The mass number of magnesium times how many, plus the mass number of phosphorus times how many, plus the mass number of oxygen times, we have here 8 oxygens. Okay, and so on for barium nitrate. Please sit down and try these so that you understand how to get molecular mass. Now, also, if we have something, for example, this is sodium hydroxide. Now, we get the molecular mass, that is the mass of sodium plus mass of oxygen plus mass of hydrogen. So the total molecular mass of sodium hydroxide is 40. Now, if he says he wants to know the percentage composition, what is the percent sodium in here? What is the percent oxygen, the percent hydrogen? You should realize that percent of anything is that thing over the total times 100. So percent sodium is the part for the sodium, which is the 23, over the total times 100. The percent oxygen is the part for the oxygen over the total times 100, and so on. This is how you get the percent of each element in the compound. So let's do some questions. So here he's saying, what is the relative molecular mass of HNO3? Again, you're going to bring the periodic table. Hydrogen has a mass of 1, nitrogen has a mass of 14, oxygen has a mass of 16, but I have 3 of them. So the total here is 63. Okay? If he's saying which relative molecular mass is not correct, so again, we said for these multiple choice questions, please be careful. Is he asking which one is correct or which one is not correct? So here he's asking which one is not correct. So let us take a look at the molecular mass of ammonia. He calculated the molecular mass of ammonia as 17. Is that correct or wrong? Yes. Nitrogen is 14. I have 3 hydrogens. Each of them has a mass of 1. So yes, 17 is correct. Now, molecular mass of carbon dioxide. Carbon is 12, and I have 1 of them, plus oxygen is 16 times 2, so that makes 44, so it's correct. Methane is CH4. Carbon is 12, and I have 4 hydrogens, so it is 16. Now, what about oxygen? Oxygen is O2. O2 means it is 16 times 2, so that is the wrong calculation, so that's my answer. A compound has this formula. How should the relative molecular mass of this compound be calculated? Well, if you sit down and calculate the molecular mass of this, I have carbon. Carbon is 12. Now, how many carbons total do I have in that compound? I have 2. So 2 times 12. Plus, hydrogen is 1. I have how many? I have 4. So that is 4 times 1. Plus, oxygen is 16, and I have 2 of them. If you look at your choices, the correct answer is D. This one says relative formula mass of copper sulfate is 160. Which mass of sulfur is present in 160 grams of copper sulfate? Well, if he says that the total is 160, the MR is 160. So if I have 160 grams, you can see from the formula that I have one sulfur. And the molecular mass of that sulfur is 32. So if I have a total of 160 grams, then I have 32 grams of sulfur because I have one sulfur in that formula. Water is formed when 48 grams of oxygen combine with 6 grams of hydrogen. So what mass of oxygen combines with 2 grams of hydrogen? This kind of questions are a direct cross multiplication. So he's saying oxygen. If oxygen is 48, hydrogen is 6. You have how much oxygen if hydrogen is 2? We just do cross multiplication, 48 times 2 divided by 6. So my answer is B. Now, this kind of questions is called a ball and stick model. And each ball represents an atom. Now, how do I know which ball is which atom? Well, we look at how many bonds or how many sticks are coming out of each ball. So if we look at the black balls each have 4 bonds coming out of them. So first of all, if we say it's an organic acid, if you've done organic compounds, you should know that they are made up of carbon, hydrogen, and oxygen. So one of these balls represents carbon, another represents hydrogen, the other represents oxygen. So the black balls have 4 bonds. Now, which of these elements forms 4 bonds? Well, in order to form 4 bonds, it has to be in group 4 with 4 electrons in its outermost shell. So that means that each of these black balls is actually carbon. Now, the white balls have only one stick attached to it. That means it has only one bond. Now, which element makes only one bond? Well, you should know it's hydrogen because hydrogen has 1 electron and it needs 1 more in its first shell. So hydrogen makes only 1 bond. So the white balls are hydrogen. Now, what are the gray balls? The gray balls are making 2 bonds each. Which one needs 2 electrons? Oxygen is in group 6, it needs 2 electrons. So that means that the black balls are carbon, hydrogen is the white balls, and the gray balls are the oxygen. So this is the formula of the compound. If you sit down and calculate the molecular mass of this, I have 12 of mass of carbon times 3 of them, plus 1 mass of hydrogen times 6 of them, plus 16 the mass of oxygen times 2 of them. So the total is 74. Okay, here he's saying the relative formula mass of calcium carbonate is 100. What is the mass of carbon in 100 grams? Again, calcium carbonate total MR is 100. So if I have 100 grams, first of all, the calcium carbonate has how many carbon atoms? So one molecule has 1 carbon atom. So if I have 100 grams of calcium carbonate, then I will have 1 of carbon that has a mass of 12. Okay. Here, this is a straightforward question. He's saying calculate the relative formula mass of zinc chloride. Again, look at the periodic table. What is the big number for the zinc? The zinc is 65 and I have 1 zinc. Plus chlorine has a mass of 35.5. Do we understand how to get that from the periodic table? The big number, the mass number, multiply by 2, the total is 136. The same here if he's telling me to calculate ammonia. Ammonia, nitrogen is 14 plus 3 hydrogens, that is 17. Now, this kind of questions, he's saying 50 tons of impure cast iron from the blast furnace. Let's keep the blast furnace aside for now. This is a method of extracting iron. Whether you've done the chapter or not yet, it doesn't make a difference with this question. So he's saying if I have 50 tons of impure cast iron, it contains 47 tons of pure iron. Calculate the percent impurity. Now, if I have 50 tons total, 47 of them are iron. That means that the rest is the impurity. So percent impurity will be the rest of the 50, which is 3, over the total times 100. Sometimes he asks for percent impurity, and sometimes he asks for percent purity. If you were asking for percent purity, I will put the mass of the iron over the total times 100. He's asking here for percent impurity. You add the difference between them, which is the impurity, over the total times 100. Again, calculate the relative molecular mass of this. So you look at xenon in the periodic table. Xenon has a mass of 131, plus fluorine has a mass of 19. I have two of them, so that is 116. This question says each electrolysis cell makes 212 kilograms of aluminium per day from 400 kilograms of aluminum oxide. That means the aluminium, I have 212 aluminium from 400 of aluminum oxide. Now, how much aluminium from 1000 kilograms of aluminum oxide? Again, this is straightforward cross multiplication, and that gives you the answer. These questions should be relatively easy. If you're not sure of them, please try and solve them again on your own. Again, this one basically says the same thing. A student obtains 24 grams of magnesium sulfate from 4.8 grams of magnesium. Now, how much magnesium sulfate from 1.2 grams of magnesium? Again, from the cross multiplication, it's 24 times 1.2 over 4.8. A sample of 20 grams of impure magnesium sulfate contains 19.5 grams of magnesium sulfate. Again, here he's saying calculate percentage what? He's saying calculate percentage purity, but we're going to put the mass of the pure magnesium over the total times 100, so it's 97.5% pure. Relative formula mass of ammonium nitrate. Again, in order to do that, you have to write the formula of ammonium nitrate first. Again, how do we write the formula of ammonium nitrate? Ammonium is NH4, nitrate is NO3. The valency of ammonium is 1 and the valency of nitrate is 1, so we don't write anything under any of these. Now, calculate the relative formula mass. Nitrogen is 14 times how many nitrogens? I have 2 nitrogens, plus hydrogen has a mass of 1 times how many hydrogens? I have 4, plus oxygen has a mass of 16 times how many? 3. Okay, again, calculate the molecular mass of sulfur dioxide. How do I write sulfur dioxide? Again, we said sulfur is S. The word dioxide means I put an O2 next to it. So this is formula in which you forget about the valencies. When he said monoxide, dioxide, trioxide, you just put 1 or 2 or 3 oxygens next to the element, and that's it. So again, the molecular mass will be 32 for sulfur plus the 16 of oxygen times 2 because I have 2 of them. Here he's saying when 64 grams of sulfur dioxide react with excess oxygen, 80 grams of sulfur trioxide is formed. Calculate the mass of sulfur trioxide formed from 160 grams of sulfur dioxide. Do we understand how to do this now? It's a cross multiplication and you get the answer. Now, this is another kind of question where he says the table shows the mass of various compounds obtained when we have 500 centimeter cubed of seawater. Then he says calculate the mass of sodium chloride present in 5 grams of the solid. So if I look at the table, it says sodium chloride is 14 grams in a total mass of 20. So this is 14 grams in a total mass of 20. He wants how much in 5 grams? So again, 14 in 20. So how much in 5? Here he says a sample of bauxite ore had the following. If you don't understand the meaning of bauxite ore, doesn't matter, doesn't make any difference with the question, we move on. Calculate the percentage of aluminium oxide in this sample of bauxite. So he has aluminium oxide is 120 grams. And he wants the percentage in the total, and that means that you calculate what is the total mass. If you add 120 plus 30 plus 40 plus 10, they come out to be 200. So it is 120 over the total times 100. That's your percent aluminium oxide. Write the simple equation for decomposition of limestone. Well, calcium carbonate will break up to give calcium oxide plus carbon dioxide. And then he says when 50 grams of calcium carbonate is decomposed, 28 grams of calcium oxide is formed. Now calculate the mass of calcium carbonate needed to produce 8.4 grams of calcium oxide. Again, calcium carbonate is 50, it breaks down to give 28 of calcium oxide. So how much calcium carbonate do I need to give 8.4 grams of calcium oxide? So that will be 15 grams. This is again another type of question. First of all, he gives you the formula and then he says how many nitrogen atoms are there in a molecule of this compound. Well, calculate, count them. 1, 2, 3, 4. I have 4 nitrogen atoms in this molecule. Now he's saying complete the table below to calculate the relative molecular mass of this compound. Again, we said relative molecular mass is just the addition of all the masses. So carbon, he's telling me I have 12 carbon atoms and each of them has a mass of 12. So the total for the carbon is 12 times 12. Now what about hydrogen? How many hydrogens do I have in that molecule? Can you count them? If we count them, they come out to be 12 hydrogens. Now what is the mass of each hydrogen? So the total will be 12 times 1. Now nitrogens, we said how many nitrogens do we have? We have 4. What is the mass of each one? 14. So 14 times 4 is 56. So the relative molecular mass of the compound is the total of all of this. So it's 144 plus 12 plus 56. Okay? Again, he's saying when 13 grams of zinc reacts with sulfur, 19.4 grams of zinc sulfide is formed. Now calculate the mass of zinc sulfide formed when 3.25 grams of zinc react completely. These types of questions are being repeated, but it is very important, especially if you are in the pre-IG stage. Okay, which metal ion in this list is present in the highest concentration? Now he's giving me ions and the amounts of each one. He's asking for a metal ion. Do we know what are metals? We should know which of these in the table are metals. Calcium is a metal. I have 32 of them, 32 milligrams. Which one else? Chloride, hydrogen carbonate are not metals. Magnesium is a metal. That's 8 milligrams. Now, nitrate is not. Potassium is a metal. That's 0.5 grams. Sodium is a metal, 4.5 grams. So the metals in here are calcium, magnesium, potassium, sodium. Which of them is present in the highest concentration? So of course it is calcium. Now he's saying calculate the amount of magnesium ions in 5 liters of this sample of water. So what do we have here? We have the amount of magnesium. Where is magnesium? Magnesium is 8 milligrams per liter. Can you see that? So if I have 1 liter, it has 8 milligrams. So he wants how much in 5? Of course, you multiply by 5. Okay, this is another question. He says the table shows the mass of some ions present in 500 centimeter cubed bottle of mineral water. Calculate the mass of magnesium in 100 centimeter cubed. Now, where is magnesium? Magnesium, he says, is 11.6 milligram in the 500. And he wants how much in 100? So again, with a cross multiplication, you get that it is 2.32 grams. This question says when 14 grams of lithium react with water, 4 grams of hydrogen are formed. Calculate the mass of hydrogen formed when 70 grams of lithium. Again, a cross multiplication. Okay, this question says, I have a bottle of mineral water and he gives me concentrations and he says, calculate the mass of sodium in 200 centimeter cube. Now let's look at the table. Where is sodium? Sodium is 1.22 milligram in 1,000 centimeter cube. And he's saying how much in 200 centimeter cube. Again, cross multiplication will give you the amount. Okay, relatively easy. This is another question where you have the table and he tells you to get the molecular mass step by step. So we have uranium compound. Uranium, it has one uranium atom and the molecular atomic mass of uranium is 238. Now oxygen. How many atoms of oxygen do I have in that formula? I have 2 of them. The mass of each one is 16, so the total is 2 times 16 for the oxygen. Fluorine, I have 2 fluorines. Each fluorine has a mass of 19, so it is 2 times 19. If you add 238 plus 32 plus 38, that comes out to be the overall relative formula mass, 310. Okay, thank you very much for listening. I hope it has made this type of question a lot easier, and please keep listening to the video.